Good morning dear students, welcome to my video. In previous video, we have learned about how to represent an irrational number on number line. So now we are going to learn how to locate real numbers on number line. In last section, we have seen that any real number has a decimal expansion. So that you have to use it for locating a decimal number on number line. The method we are using is successive magnification. Successive magnification. So using successive magnification, each number we are getting a correct point on the number line. So for example, one example I will show you. Number 2.665. 2.665, after decimal 3 digits are there, 6, 6, 5. So you have to draw 3 number lines to get the correct point of 2.665. This decimal actually lies between 2 and 3 because it is 2 point. So it lies between 2 and 3. So first you have to write the given number or decimal lies between 2 and 3. So if we look closely at the portion of only the 2 and 3, we can see on the scale we can see 10 equal parts between them. So we are just magnifying that portion between 2 and 3 and drawing one number line. This is the first number line. See, I have drawn here 2 and 3 and in between 9 points. 1, 2, 3, 4, this is 5, half, 6, 7, 8, 9. 9 points means 10 parts you will get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So equal 10 parts you will get if you are putting 9 points. So in between 2 and 3, that scale small 1 centimeter I have magnified here and shown as 2 in between 2 and 3, 10 points. This all shows millimeter only. So now you can mark it. First one will be 2.1. Second one will be 2.2. Third one will be 2.3. Like that, 2.4. Middle one it is 2.5, 2.6. 2.7, 2.8, 2.9 and next will be 3. So this is the magnified form of number line in between 2 and 3. Now where this number lies in this number line, that means only one decimal you can show. First decimal if you are taking means it is 2.6 and after that it is continuing 2.665 is there. So in between 2.6 and 2.7 only this number lies. Since it is 2.665, the number lies between 2.6 and 2.7. That means this portion. So that portion alone you have to magnify and show it in the second number line. Only this portion you have to take and draw. This portion again you have to mark it as 10 points, 10 parts. That is 9 points you have to mark. So that we will see. Just see the second number line. See, I have marked here. So only this portion we are focusing and magnifying it and marking it as here it will be 2.6. First point will be 2.6 and the last point will be 2.7. So understood, here only this portion you have magnified. You are focusing there only. So in between 9 points will be there. 1, 2, 3, 4. This is the half portion. 6, 7, 8, 9. So 9 points will be there and 10 parts will be there. First part, second, third, 4, 5, 6, 7, 8, 9, 10. So 10 parts will be there. So each one you have to mark it as 2.61, 2.62 like that. Second point is 2.62, 2.63, 2.64, middle one 2.65, 2.66, 2.67, 2.68, 2.69. So this is the way you are magnifying only this portion and drawing it. So in between 2.6 and 2.7 we have marked now. So this magnifies means you have to keep a scale and draw the line there. So from this point to 2.6, this point you are magnifying and drawing. So like this one line, and from here also last point one line. So now understood, only this point, this position, this part you are magnifying and drawing it as a big line. So now where the number lies? 2.665. So in between 2.66 and 67. So here the number lies 2.66 and 2.67, but you don't know exactly where that point lies. So for finding out that, this portion you have to magnify it again. Focus only that point and draw another number line in between 2.66 and 2.67. See here, I have magnified that and drawn next number line. That is third number line here. This is first one, second one, third one. Now this is in between, that number is in between 2.66 and 2.67. So mark here 2.66 and 2.67. So in between what will be the first point? 2.661. So that is 2.661. Second one will be 2.662, 2.663, 2.664. Middle one it is 2.665. Next 2.666, 2.667, 2.668 and 2.669. So this is the number line, new number line. So here the number where it lies, you should say 2.665 where it will lies. Clearly it is lying here. So this is the position of 2.665 on number line. So here in between, when you will draw the second number line, here you have to write it lies between 2.6 and 2.7. Here you have to write the number lies between 2.66 and 2.67. So this is the way of locating a decimal point on number line exactly by using successive magnification. You are magnifying each portion and getting a clear point on the number line for the given decimal. Hope you understood, children. One more sum I will show you. Second question. Visualize 1.32 bar, only 2 bar on a number line. That means only 2 is repeating, using successive magnification up to 3 decimal places. So 3 decimal place only you have to write. So the number you can write it as 1.3222 etc. This is the number. So here only 3 decimal places you have to write. That means 1.322. So till there only you have to find. So here also after decimal 3 numbers are there. So 3 number line you have to draw. After decimal how many digits are there? According to that you have to increase your number lines number also. After decimal point if 6 digits are there means you have to draw 6 number line. After decimal if it is only 2 digit means only 2 number line is enough. So here 3 digits are there. So 3 number lines you have to draw. We will see that how you will draw. So the number 1.322 lies between which 2 whole numbers? Obviously it is lying between 1 and 2. So you have to draw first number line in between 1 and 2. Magnified form in between 1 and 2. We will see that first number line. So this is in between 1 and 2. The number lies in between 1 and 2. You should write here the given number lies between 1 and 2. Now mark that first point. It is 1.1, 1.2, 1.3, 1.4, middle point 1.5, 1.6, 1.7, 1.8, 1.9, last one is 2. So now where the position of 1.322 it will come? It will be in between, obviously it will be in between 1.3 and 1.4. So starting number is 3, so it will start from here only. So 1.3 and 1.4, the number lies in between this circle, 1.3 and 1.4. So in the next number line, you have to show that in between 1.3 and 1.4 in the magnified form. So that only I have written here in a second number line. So it will be in between 1.3 and 1.4. You can draw the lines like that. Both the sides lines you can draw. So this shows only this part you have magnified and shown. So here first point denotes 1.31. Next point denotes 1.32, 1.33, 1.34, 1.35, middle point 1.36, 1.37, 1.38 and 1.39 last. Next one is 1.4 it will come. So now tell me where that number lies, 1.322. So this is 1.3, second number is 2. So it will start from here only. So 1.32 and 33 here. So this will be in between 1.32 and 1.33. Here somewhere only it will lie. So again third number line you have to draw in between 1.32 and 1.33. So again next number line 1.32 and 1.33. Now magnified form of that small portion in the scale. So that is 1.321 you have to start. 1.321. Second point is 1.322, 1.323, 1.324, 1.325, 1.326, 1.327, 1.328, 1.329 and last one is 1.33. So you have magnified that small portion like this on a number line. You can draw this lines also. You can, here you have to write the given line. The given point number lies between 1.3 and 1.4. And last number line you have to denote 1.322 lies between 1.32 and 1.33. So now draw the scale that lines. Now where is the exact point of 1.322? So in this number line only you can see it is visible here. This is the point 1.322. So exact point on the number line you have magnified and shown. So this is the process of successive magnification, and this one any number, any decimal number if it is given also you can draw using successive magnification. This is the way of representing a real number on number line. So if it is bar, it has come, for example 1.32 whole bar if it comes also, you can write like this 1.32, 32, 32 and take how many decimals in the question they have asked. You have to take that much decimal and draw the number line. Depends on decimal number, after decimal how many digits are there, depends on that. Number of number lines also you have to increase or decrease. Next topic is operations on real numbers. Operations means fundamental operations only: addition, subtraction, multiplication and division of real numbers. Real numbers in the sense it can come rational or irrational. So, first one few rules are there for that. First we will discuss the rules. The sum or difference of a rational number and an irrational number. A rational number and irrational number, if it is addition or subtraction, the result will be an irrational number only. So, for example, I will show you a rational 2 and an irrational number. This is subtraction of a rational and irrational number. So, you can't do anything with that. You can't simplify also. This will be the final result. So, this will be an irrational number. So, 2 minus root 3 or 2 plus root 3. If addition or subtraction comes also, it is irrational only. Result is irrational. This is the first rule. If it is addition of rational and irrational number, answer will be always irrational. Second point is the product or quotient, that means multiplication or division of rational or irrational number. It is always irrational. For example, 4 into root 3, that we will write as 4 root 3. We will not write this into 4 root 3, means 4 into root 3 only. So, this result is always irrational only, because root 3 is irrational, whole number is irrational. Similarly, if it is 8 by root 2, rational number divided by an irrational number, the result is always irrational. So, addition, subtraction of rational and irrational, multiplication and division of rational and irrational, it is both irrational only. Now, third rule, if we add, subtract, multiply or divide any two irrational numbers, to both also if it is irrational number, if you add, subtract, multiply or divide, the result may or may not be rational. Sometimes it will be rational, sometimes it will be irrational. Examples I will show you. Root 2 minus root 3. This also you can't do anything with that. Simplification further you can't do. So, this will be the final answer. This is irrational only. Root 3 plus root 7 plus addition, sum. This is also irrational only, because further you can't do root 3 and root 7, you can't do anything. So, it will be irrational only. But root 2 plus root 2, both same if it has come, means you can add and write as 2 root 2. So, 2 root 2 also it is irrational only. So, understood? If different irrational comes, you can't add or subtract. You should write like that only. There is no simplified form for that. But same irrational number 2 times if it is coming, means you can write 2 root 2. 3 times if it is coming, means you can write 3 root 2, like that. Now, we will see multiplication and division. Multiplication, root 2 into root 3, two different irrationals. You can multiply it and write 2 3s are 6, root 6. But root 6 also you can't further simplify, so that is irrational only. But root 2 into root 2, same two irrational number comes, it will become root 4, 2 into 2, 4, answer is 2. Root 4 is 2, you know that. So, a perfect square number if it comes, root of a perfect square number, you can remove the square root symbol. So, 2 is a whole number, or you can say it is a rational. So, all these cases here it was irrational. So, now see here it is rational. All these cases it was irrational. This is rational. So, similarly for division also, root 2 by root 3, you can't do anything. This is irrational. But same things, root 3 by root 3, same number comes, you can cancel it off, answer will be 1, which is rational. So, some cases rational number will come, some cases irrational number will come if both the numbers are irrational numbers. So, if we add, subtract, multiply or divide any two irrational numbers, the result may be rational or irrational. This is the third rule. So using this, you can classify whether given number is rational or irrational. So for example, 2 minus root 5, it is irrational. But 3 plus root 23 minus root 23, is it rational or irrational? You can cancel this. Answer will be 3. So it is rational. 1 by root 7, it is irrational. Pi if it comes, 8 pi, it is irrational. So I will give you homework, some few questions. You have to change it to rational and irrational. Okay. Next topic is identities related to irrational numbers. You know algebraic identities you have learned already. A plus b the whole square. First identity, a plus b the whole square is equal to a square plus 2ab plus b square. Just recall, a minus b the whole square is equal to a square minus 2ab plus b square. If it is a plus b into a minus b, what will be the answer? It is a square minus b square. If it is a plus b into c plus d, 4 also different means a into c ac plus like this ac plus ad plus bc plus bd. So this is next identity. So all these 4 identities we have already learned. So using this, if it is an irrational number, how you will find the answer? Before, a few more rules are there. Root a into root b is equal to root of ab. You can multiply these both and write in single root. Similarly, root a by root b is equal to single root, you can write root a by b. Then you can see root of a square equals, what is root of a square? That is root of a into a you can write, correct? Then 2 times if it is repeating inside the square root, 1 time you can remove it outside. This is very important. Root of b square is equal to b. Root 2 the whole square is equal to 2. The root symbol only will go. Root 5 the whole square is equal to 5. Root 7 the whole square is equal to 7. Any prime number comes also, any irrational number comes also. Root 11 the whole square is equal to 11. 2 times if it is repeating means you can remove the square root and write. This is very important. You have to use in between the sums. Now we will see the exercise sums. Exercise 1.5. First main is classification, that I will give it as homework. I have already taught you how to write the rational and rational numbers. Second main now, simplify. So you have to use here identities. First one, 3 plus root 3 into 2 plus root 2. See, 3, root 3, 2, root 2. Different. All 4 are different. So you have to use the fourth identity, a plus b into c plus d is equal to ac plus ad plus bc plus bd. Directly you can write, no problem. So 3 into 2, first one, and second one 3 into root 2. Next root 3 into 2 and root 3 into root 2. Like that you have to expand it and write. So 3 into 2, first one, plus 3 into root 2, 3 root 2, no need of into simple there, plus root 3 into 2, 2 root 3. Always you have to write the number part starting only, because that is called the coefficient. So number part second value you should not write. Number part always first and then irrational number you should write. Plus last one, root 3 into root 2. Now simplify it. 3 2s are 6 plus 3 root 2 plus 2 root 3 plus root 3 into root 2 is root 6. Here you can multiply. But this both addition is not possible because root 2 is different, root 3 is different. If it has come like that different, you should not add or subtract. Understood? So this is the final answer. You can't simplify further. So this will be the result. Second sum, 3 plus root 3 into 3 minus root 3. Which identity is this? A plus b into a minus b identity. So what is that identity's answer? A square minus b square, that is equal to a square minus b square. You can write the identity in the side. A plus b into a minus b is equal to a square minus b square. This identity you are using here. So a is 3 and b is root 3. So a square means 3 square and b square means root 3 the whole square. How much is 3 square? It is 9 minus root 3 square how much? You can remove the square root and write 3. I have already told you any irrational number square if it comes means without square root you have to write, because root 3 whole square means it is root 9. Root 9. 9 is a perfect square number, that is 3. So 9 minus 3, that is 6. So 6 is the final answer. Hope you understood that. Two identities now we have used. Now we will see the third sum. Root 5 plus root 2 the whole square. Which identity you have to use here? Yes, a plus b the whole square is equal to a square plus 2ab plus b square. So root 5 plus root 2 the whole square means a is root 5, b is root 2. That is equal to root 5 the whole square plus 2 into root 5 into root 2 plus root 2 the whole square, which is equal to root 5 whole square how much? Same like this. Number part you have to remove it outside the square root, plus this both you can multiply it and write 2 root 10 plus root 2 whole square, it is 2. So 5 and 2 are the number part, that is whole numbers, you can add and write. So 5 plus 2 it is 7 plus 2 root 10. 2 root 10 you can't do anything. Here you have to stop it. Further you can't move also. So this is the final answer. So third identity also. Fourth identity, that minus if it comes means only here it will change, remaining all same only. So hope you understood children. Some few homeworks I will give. So correctly with full concentration you have to do. Same type of sums I will give. So these are the homework sums children. Exercise 1.4, first one, visualize 3.765 on a number line. Locate 4.26. Visualize 4.37. Here only sub for 7 bar. Here for 2.6 also bar is there. So 2.6, 2.6, 2.6. You have, like that you have to repeat 3 decimal places you have to take. Here 4.3777. Like that 3 decimal places you have to take. Next exercise 1.5, first main, classify the following as rational and irrational. These numbers example sums I have given. See that, concentrate and do it. Second one, simplify by using identities. Root 7 plus root 5 the whole square, root 3 minus root 2 the whole square, root 7 plus 2 the whole square, 2 plus root 7 into 3 minus root 2 and root 7 plus root 5 into root 7 minus root 5. All the 4 identities you have to use. So practice all the sums children. Daily practice 1 hour. Then you can excel in mathematics. So thank you children.